Now here's one more that's going to have some fractions, and so I titled this one, really, don't be afraid of fractions, all right? I know some of us don't love fractions, but once you get the hang of it, and we remember, we need common denominators when we add or subtract, and when you multiply, it's just multiply straight across, then life's not too difficult. So let's watch what happens. We're going to, before we do anything, we want, our goal here is to make this x squared plus bx. That's our goal. We want to make it look like that. So that means we got to get this 5 out of there. That's the first thing. Always get that 5, get that constant out of there. We don't want it here. It's just kind of making a mess. 3x squared plus 2x equals 5. Now we want to get rid of this coefficient 3 here because we want it to be a 1, a little invisible 1 there. So we're going to divide by that leading coefficient on both sides. What you do to one side, you got to do to the other. And that leaves us with 3 divided by 3 is x squared. I should probably not cross it out because we've got to divide both of them here. 3 divided by 3 is 1x squared. And you got to divide this one also. Don't forget that. 2 divided by 3 is 2 over 3x. Okay. And 5 divided by 3 is just 5/3. Now we have to complete the square. So we need b over 2 squared, which is the same thing as half of b squared. And in this case, we have 1/2 of the b value, which the b value here is 2/3 squared. Get my colors right. Okay, and so this is going to be half times 2/3 is 1/3. Okay, you're going to get 2/6, which we simplify to 1/3 squared, which is 1/9. So 1/9 is the thing that we need to add to both sides. Add 1/9, add 1/9. Okay. Now we'll need to factor the left side, which should be easy. We made it so that it's going to factor perfectly. The square root of this is 1/3. Half of 2/3 is 1/3. All right. Here we need to multiply by 3 on top and bottom because we need a common denominator. That's 15/9 plus 1/9. And that's 16/9. And now it's all ready to go. We're going to square root. And we have x plus 1/3 equals plus or minus. Square root of 16 is 4. Square root of 9 is 3. And we're almost there. 2 equations. Since everything cleaned up nicely, we need to write this as 2 equations. X plus 1/3 equals negative 4/3. So positive 4/3 and negative 4/3. And subtract 1/3 from both sides here. And we have x equals 3/3, which is 1. Subtract 1/3 from both sides here. And we have x equals negative 5/3. So there's 2 answers. We need them both. Okay, a lot of fractions going on there, but just remember that dividing by 2 is the same as multiplying by 1/2. And remember that when we get this, you don't have to stress about it. It's going to factor. If you did half of b squared, then this will factor into the square root of this thing, which you should already know from that work above. All right, so here's a quick summary, all right? So solving by completing the square, here's all the steps together. Okay, so if we have this equation here, we want to isolate the variable terms. That means get that 5 out of there, add it. There we go. Then we want to divide to make that leading coefficient 1. So we divide everything by, in this case, 2. Divide everything by 2, we have x squared plus 6x plus 7. All right. Now that's looking like what we want it to be because it's a plus bx, x squared plus bx. We got to take half of the 6 and square it, b over 2 squared now. b over 2 squared is 9, so we're going to add 9 to both sides and clean it up. Then we can factor this, square root to get that squared away, and write 2 equations. If the right side comes out to be a whole or an integer, then or actually a rational number, could be a fraction, Then we're going to need to write two equations, subtract 3, and get our answers. All right? So those are all the steps together there. Hope that's making sense. Here's some more practice. This is a good one that you might want to write the problem down, pause it, and try it. You can come back and check the answer. Remember, our steps are to isolate the variable terms, get all the variables by themselves. In other words, get that constant out of there. We want to make the leading coefficient 1 by dividing, complete the square, add to both sides, and factor and solve. So if you want to pause it and try it and come back, you can do that now. All right, so here we're going to add 3 to both sides. We want to get that out of there. X squared plus 6x equals 10. And now we got to complete the square. We take half of the 6 and add it. Well, half the 6 squared. 6 over 2 squared is 9. So we're going to add 9 to both sides. And that gives us x plus 3 squared. We factor this. Square root of 9 is 3. Half of 6 is 3. So that matches. Now we've got this squared outside, so we can square root. So x plus 3 equals plus or minus the square root of 19. We're almost there. Get that 3 out of there because we're trying to solve for x. And we've got negative 3 plus or minus the square root of 19. There it is. This one already is in a plus b, x squared plus bx form. That's the form we needed, x squared plus bx. So we just need to add to both sides. What are we going to add? We're going to add half of 3 squared. 3 divided by 2 squared. Well, that's just 3 halves squared. If you square the top, you get 9. Square the bottom, you get 4. So we need to take x squared plus 3x, and we need to add 9 quarters. And what you do to one side, you got to do to the other. Now again, don't stress too much. This is going to factor. It's going to factor into x plus half of 3 is 3 over 2. And the square root of 6/4 is 3 over 2. This guy here, all right, this is 2 over 1. So we're going to multiply by 4 on top and bottom because we need a common denominator. And that's going to be 8 plus 9, which is 17. Now we're pretty close. We just need to get rid of that squared because we pulled the square out so we can square root. And we're going to end up with x plus 3 halves equals plus or minus the square root of 17 all over the square root of 4. You got to square root the top and bottom, remember. The square root's the whole thing. Square root of 4 is 2. So in this case, we can square root the bottom, but we can't square root the top. Okay? And finally, last step is we want to subtract 3 halves from both sides. Okay? Now we can write this in a couple ways. We could write it as x equals plus or minus square root of 17 halves minus 3 halves. But since that's a common denominator, we'd like to put it together. And we like to have the square root last, so we'll usually prefer to write this as negative 3 plus or minus the square root of 17 all over 2. So positive square root of 3, negative square root of 3, negative 3 plus the square root of 17 divided by 2, that's one answer. Negative 3 minus the square root of 17 divided by 2, that's a second answer. All right, and if you want a decimal value, you can go plug that into a calculator. And all right, one last one. This has kind of everything here, at least all the steps. We got to get that 3 out of there first. Don't forget to do that first. We still have 2x squared plus 8x. The 3 is gone, and we got a 10. And now we got to complete the square. So we ask ourselves, oh, nope, not yet. Got ahead of myself, huh? This needs to be in the form I keep saying that wrong. X squared plus bx. In other words, the number in front needs to be 1. Is that 1? Nope, it's not. So we've got to divide both sides by 2. That's everything by 2. And then we need to add, now we can complete the square. So our b value is 4. So we're going to take 4 over 2 squared. That's going to be 2 squared, which is 4. So we're going to add 4 to both sides. And we get x. Oh, we're going to factor, actually. So we can factor this. The square root of 4 is 2, and half of this 4 is 2. So 2 is what we need to add. And then we can finish it off with square root. So we end up with x plus 2 equals plus or minus 3. And we should write that in 2 problems, 2 equations, I should say, because we're going to be able to go to simplify it completely. Subtract 2 from both sides, we get 1. Subtract 2 from both sides, we get negative 5. All right, 2 answers. There they are. Okay. So again, big idea. We want to get the constant out of there. Divide by the leading coefficient so that we get a 1 in front. That's important. Then we take half of the b value squared, which happens to be the same number. 4 is special in that way. Add it to both sides. Okay. And then finish it off from there. Write 2 equations if needed. Okay. All right, hope that helps to get a good understanding of how to use completing the square. Completing the square is a powerful method because it always works. Sometimes it gets a little weird and ugly with square roots and fractions, but it will always work. You can use this on any quadratic equation. Thanks a lot.